My name is Duc Anh Nguyen from Sustainable Wastewater Treatment Laboratory under Professor M. Zhang. Today, the topic of my presentation is magnetic adsorption and FD-FO membrane separation hybrid system for hydroponic irrigation from rich heavy metals containing arsenic wastewater. But before starting my presentation, I would like to ask all of you one question. Have you ever experienced arsenic contamination in your life? I hope that your answers will be no. But unfortunately, this is not the same case for everyone around the world, because half of the countries around the world right now are severely impacted by arsenic poisoning. And it's even worse because more than 250 million people worldwide are negatively poisoned by arsenic contaminant. We can see that arsenic contamination is not new, but why arsenic regulations still have been provided year by year? The answer is this problem is still alarming. So to remove arsenic, several technologies have been involved. But I found that most of them could not work effectively, especially when arsenic concentration is high, like 50 or 100 ppm, except for adsorption and membrane separation. However, for adsorption, most of the coexisting ions cannot affect the adsorption performance, which means all the contaminants are still in the solution and we cannot use the final solution directly. So how about membrane separation process? We can extract multi-contaminant at the same time. Well, according to the existing papers, membrane separation cannot remove arsenic-3 well. Therefore, an integration process between adsorption and membrane separation is very necessary. So this is how our hybrid system works. First of all, most of the arsenic-3 will be removed by adsorption process. So to enhance the convenience of using, I designed a magnetic adsorbent that can be separated quickly by applying a magnet. Then, the remaining contaminants, such as heavy metal ions that can negatively affect the plant growth, will be removed by forward osmosis process. Here, I decided to use forward osmosis because it can work more effectively in a large range of arsenic concentration and it consumes less energy. But if I want to use forward osmosis process, I have to find a solution for indirect use draw solution problem. To solve this issue, a blended fertilizer mixture as raw solution was used to provide a favorable nutrient solution for hydroponic irrigation. Now, let's take a look at the results. First of all, I would like to show you the characteristics of the magnetic adsorbents. In general, from all of the analysis, I can conclude that cobalt iron oxide, Mu100 and manganese oxide have been connected successfully to each other. So how about the adsorption performance? Well, first, this material can remove both types of arsenic well in a large range of pH. And this is very suitable for the next membrane separation process. Second, this material can remove arsenic pretty fast. It could remove 90% of arsenic within 20 minutes, the first 20 minutes, and reach equilibrium time at 60 minutes with two processes happening at the same time, oxidation and adsorption. It also shows competitive adsorption capacity around 175 mg per gram for arsenic-3 and 126 mg per gram for arsenic-5. So until here, we can say that 50% of my research was considered to be successful. Now let's move to the other 50%, which is a long-term FD-FO process. Similar to arsenic-5, all the heavy metal cations were removed, around 100%. However, when it comes to arsenic-3 removal, well, the rejection rate is just 25%, which is very low. Therefore, a pre-treatment for arsenic-3 is necessary. But the good news is I successfully created a suitable fertilizer mixture of NPK that could help us to produce a suitable nutrient solution for hydroponic irrigation. So that's all about investigating each process separately. Now I will show you the performance of the hybrid system. In short, after integrating two processes, we finally produce suitable nutrient solution with no arsenic and no other heavy metal cations. Now, let's summarize our results. First of all, I already successfully synthesized a new magnetic material with good stability, fast rate, high capacity, excellent interference tolerance capability. However, only adsorption process using this material is not enough for actual application. And similar to FDFO process, only membrane separation is also not enough. But after combining two processes, we effectively remove arsenic, all the coexisting heavy metal cations, and produce a suitable nutrient solution for hydroponics irrigation. So to support this article, I would like to show you the supplementary document for adsorption and FDFO part. This is the end of my presentation. Thank you so much for your attention.